This machine is bigger than a truck, heavier than imagination, and powerful enough to drive an entire factory.
The voltage requirement for the new motor design is higher than anticipated.
The thermal analysis shows we need better airflow around the casing.
The induction motor is robust, but the synchronous offers better efficiency at high speeds.
Right, but what about the power factor correction needed for the synchronous?
To determine the required power for the industrial load, we calculate the torque at the operating speed.
By analyzing the magnetic flux distribution here, we can optimize the electromagnetic design for peak performance and efficiency.
The diameter is exactly 150 millimeters as specified.
Yes, but look at this imperfection on the stator winding. It could cause an imbalance at high RPM.
The bill of materials ensures precise material procurement and assembly accuracy, minimizing errors in the production process.
Prototype planning allows us to rigorously test the design assumptions before committing to full-scale production.
Check the gauge on the silicon steel first.
Looks consistent. The insulation coating is uniform as well. Sign off on the delivery. We need to align the die precisely for the lamination cut.
Okay, making sure the measurements match the blueprint now.
High-speed stamping is essential for creating the precise rotor and stator laminations you see here, directly impacting the machine's electrical efficiency. By applying this precise edge insulation, we can effectively prevent the formation of eddy currents, which ensures the longevity and efficiency of the lamination. Deburring is essential. It protects the delicate windings from damage and ensures the highest quality in the final assembly.
Our climate-controlled facility ensures optimal conditions. We meticulously monitor temperature and humidity to
A little more to the left, watch that gap.
Got it. It's sliding in smoothly now.
Nice work, perfectly aligned.
Check the alignment gauge, it's fluctuating.
Adjust the calibration dial slightly counterclockwise.
It's settling now. That looks accurate.
We inspect the slot insulation carefully, as it's crucial for preventing short circuits and maintaining the lifespan of the equipment.
As the varnish is applied, it reinforces the mechanical strength and ensures superior electrical insulation across the entire stator surface.
Accurate identification is crucial here. These batch and phase numbers ensure complete traceability for quality control and streamline the assembly process down the line.
The completed stator is now ready for the precise coil winding in the next phase of assembly.
Okay, the alignment looks good.
Did you verify the tension settings on the HMI?
Yes, calibrator checked out fine. Ready for the first run.
The insulation class here is borderline.
The gauge checks out for quality acceptance.
Okay, send it through.
Resistance testing ensures correct electrical continuity and balance. The completed winding is inspected and then approved via sign-off, clearing it for the high-voltage insulation and impregnation process.
Make sure we get all the dust out of these windings before we wipe it down.
Absolutely. Any residue left will compromise the VPI process.
Looks good.
The vacuum levels are stable at 20 torr.
Check the resin viscosity next.
It's within specification. Safety checks are complete.
The controlled heat cures the resin and locks the insulation in place. The VPI process ensures long-term insulation durability and electrical reliability for the next assembly stage.
The straightness tolerance on this journal looks good.
The micrometer confirms
It's within spec.
and the material grade is exactly what we requested.
Ensure the stacking order is correct before we lower it. Now align it precisely with the marks for the press fit.
Roger that. Coming down slowly.
This machine ensures precision dynamic balancing, minimizing harmful vibrations and dramatically extending the lifespan of the bearings. The engineer has reviewed the data and given her approval. This rotor is now ready for stator integration and final motor assembly.
We've got a slight imbalance on the rear cable.
Adjusting trim now. How's the air gap look on your side?
Looks good. Clear to land.
We need to ensure these journals are pristine. The tolerance sensitivity on the bearing surface is paramount for installation.
Confirmed. Looks good here.
Readings stable. Axial position confirmed.
Radial alignment holding steady.
Step 65 complete.
Precise alignment prevents vibration, improves efficiency, and ensures long service life.
This is the completed assembly, the mechanical heart of the 500 kilowatt motor, combining the stator and rotor into a single unit.
We need to ensure the lithium complex is applied evenly here.
Absolutely, and check for any contaminants in the inner race before we finalize the prep.
The expansion tolerance looks good at 200 degrees Celsius.
Agreed. We are well within the limits for the press fit.
The clearance is within tolerance at 5 thousandths.
Axial marks confirmed. We are ready for housing closure.
Assembling the housing correctly ensures both reliability and a long service life for the unit. The assembly is now complete, finalizing the motor's primary mechanical structure and sealing the internal components.
The airflow needs to be strictly unidirectional here. Look at the thermal specs.
Right. And the mounting orientation is critical to avoid recirculation. The rotation needs to be strictly clockwise. Verify the pitch setting with the gauge.
Reading 22 degrees. Matches the spec sheet exactly.
All right, these are secure. How's the spacing on your end? Looks good, right within the OSHA guidelines.
Step 87, fastening the cooling components. As the torque tool secures the bolts, the sealants and gas
Clearances look good here. How's the sensor data?
Everything is well within tolerance. We are good to proceed.
As the system operates, forced airflow is directed across the stator windings and bearings, efficiently removing excess heat.
The fully installed cooling and auxiliary systems are essential. They ensure the thermal stability and long-term reliability of the motor.
We need to verify the voltage rating on this schematic.
And ensure these insulation barriers meet the clearance requirements.
The phase layout looks good.
We have to check the conductor sizing and the insulation class right here.
And watch the bend radius. The specs are on page 12.
Got it.
For step 94, ensure the power cables are securely bolted to the stator terminals using the torque tool, verifying correct lug seating and washer alignment.
Temperature sensors, vibration pickups, and RTDs are installed into designated ports, with careful thread engagement and seal placement.
In this step, we install the terminal box cover and tighten the fasteners in sequence to ensure proper gasket compression and sealing. Proper electrical termination is critical. It ensures both safe power delivery and long-term operational reliability. Step 100, the completed electrical assembly. This motor is now ready for comprehensive testing and final commissioning.
Cross-referencing the nameplate now, everything aligns.
Good. I'm checking the fasteners on the base. All secure.
We need to verify the signal integrity on the analyzer.
The probes are connected and secure. Verified.
Looks stable. Let's start the sequence.
Step 104, High Voltage Dielectric Test.
Efficiency and temperature rise both look good according to the spec.
Agreed. Vibration is nominal. We are clear for approval.
These tests verify the safety, efficiency, and long-term reliability of the motor. Step 110 confirms it. The motor powers down, achieving final certification.
We need absolute cleanliness here. Check this seam for any residue.
Got it. I'm using the new solvent mix. It cuts through the heavy grease well.
Check the thickness readings on the tablet. The adhesion looks good visually.
Yeah, it's within the parameters. We can proceed to the next stage.
The serial number matches the manifest, and the compliance markings are present.
Verified. The nameplate is secure.
The inspection certificate checks out, but verify the compliance codes.
Right, I'll update this section now.
Okay, approved for dispatch.
Our final step, protective packaging, is crucial for safe global transportation.
Step 120 complete. This 500 kilowatt motor represents the pinnacle of engineering, ready to power industry across the globe.